Today we're going to be doing what we like to call an intro-texture webinar. It's a bit of a light touch into the architecture and also an overview of Splunk itself as well, and hopefully just a bit of an opportunity for anybody to ask any questions or any kind of things that they've been trying to do in Splunk that maybe they haven't had successful at the moment. So if you haven't met me before, my name is Grace. I head up our support team over here at Somerford, and I also do most of our pre-sales engagements and workshops and webinars like this. Now, just to give you a bit of an overview of Somerford itself, Somerford Associates are an elite partner of Splunk. We've been one of their first UK partners. Now, we're their elite partner because we're able to deal with all of your technical kind of use cases and any technical help that you need, or service desk help, or even professional services. We're able to handle that all under the one roof. So to take you from right the way through from that first initial discussion, looking at, demonstrations, whether they're on site or remote, as well as helping you build a business case, then moving on to proof of concepts, and then if they're a success, moving on to production deployments, and of course after sales support and services should you ever need us. So we can offer you that entire wrapper kind of under one roof, and it also means that when you need some help, you've got one person to call who's a friendly face and that you know well and knows you. And hopefully it alleviates that annoying habit of having to relay the same, 6 pieces of information every single time whenever you raise a case, because we already know them. Now, let's start off with just doing a bit of a high level intro into the different parts of the architecture. Now, at the bottom, we have the concept of forwarders. Now, universal forwarders or forwarders, data inputs, you may have them called data input tier. All of them do essentially the same thing. So, forwarder is a agent or client that sits on an endpoint and is able to send that data from the endpoint up into the indexing layer, which is this middle layer here, and I'll go through that a little bit later on. Now, there are two different kinds of forwarder. We've got the universal forwarder, which can be used on Linux or Windows, and that literally just goes and tells it, send the data from A to B. You can't do any complicated, filtering or transforms. It's really built just to be that kind of data sending and receiving. Now, you may have a use case where you need to, for example, strip out some parts of the event, maybe a credit card number, maybe a full name, or perhaps something internal like a status code or a name of a product that hasn't been launched yet. And all of those things and filters can be done using a heavy forwarder. Now, a heavy forwarder is essentially a full installation of Splunk that we tell to do the forwarding and receiving for the endpoint that it's on. So if you wanted to, for example, strip out somebody's credit card number, you could deploy a heavy forwarder out to wherever you're ingesting that data, or have a heavy forwarder acting as an intermediate forwarder, and then basically place some regular expressions to trap whatever it is that you want to remove from the events, and then have that removed out as it's being streamed into the Splunk indexes, which is a really great way of kind of alleviating all those audit and compliance concerns by basically kind of just trying to avoid them. Now, there's over 100 different ways to get data into Splunk. You don't have to just use the forwarders. You can use things like the REST API, TCP or UDP. You can use scripted inputs. There's modular inputs. You've got Splunk for Stream. You've got the HTTP event collector, and you also have great options like doing just like a syslog, or you can use again one of our forwarders, or you can ingest from other logging facilities, whether you've got something like Nagios or Sitescope, or if you're using another logging system like ExtraHop, then maybe you want to pull the logs in from there as well. And we can do that with a variety of methods. We can just directly monitor a log file. We can go ahead and put a folder on there and ingest, or we can use a REST API if it's from a cloud input or something like that. Now, once your data gets sent up into Splunk, you will have heard me talk about these before, they get put to our indexes. And I always say our indexes are our hardest working part of the puzzle. They get none of the glory and all of the work. So our indexes are what deal with all of your parsing, and by that I mean splitting up the events into those nice little chunks and doing timestamp and field extraction. Now, it also deals with all of your retention and role-based access, and we do this by placing data into something called indexes. Now, sometimes people get a little bit confused between indexers and indexes. So, what I like to say is an indexer is the physical or virtual or cloud server that you're running that's acting as that Splunk kind of piece of equipment. Now, the indexes are the best way to think of it as subdirectories on the back end that are just used for segregating your data off into different folders. Now, each of those different folders or subdirectories or indexes, whatever you want, whatever you feel most comfortable calling them, each of those can have individual retention and role-based access. So that's the easiest way to give yourself the most, obviously, security, and also gives you the most granular control of, who has access to what, and also how long that's being stored for. Now, at the top here, I said, our indexes get no glory, and that's really because they don't do any of the pretty stuff. They do all the hard work with none of the sexy stuff. Now, the search heads, they do all of the pretty visualizations, all the searches, reports, and alerts, all the dashboarding. They also run any applications that you might want to run. And I'll show you a little bit of the App Store and what, applications are out there a little bit later on as well. Now, our search heads, they use a Python-based web service called CherryPy, and we basically can deploy them on any OS, whether that's Linux or Windows, and they can again be across virtualized, physical, or cloud instances, depending on what deployment style you guys want and what works for your existing architecture. Now, there are also a couple of other parts of the architecture that aren't always talked about, and that is your deployment server. Now, you can have a deployment server for both things like indexes and also forwarders. Now, most commonly, they are used for forwarders, and really it's just an easy way of sending out configurations and deployments to different types of forwarders. Obviously, if you can imagine, if you're ingesting all of the different data from all your different workstations and servers, you might have done thousands or hundreds of thousands of forwarders dotted about your infrastructure. If I had to tell you that you had to manage and administrate them individually, you might not be a very happy bunny. So what the deployment server does is it allows you to make something called server classes, and they're essentially groups that you can define and then deploy config out to those individual groups, and then that will deploy out to the different folders depending on what it is. For example, the data they're collecting, or maybe if there's additional sources that you wanted to pull off some machines, then you can do that very easily using the deployment server. Now, there's also the deployment server which you can use for indexes, and that's for non-clustered indexes. I'll say that again, non-clustered indexes. So I'll talk about clusters and non-clusters a bit later on. But essentially, if you're using non-clustered indexes, you can use the deployment server to send out configurations to them. The only caveat I will say is that you do have to make sure that you are deploying out the right config to the right indexes, and also make sure that everything is common across them all so everybody has the same piece of information or same configuration files, because otherwise it can cause some conflicts there. Now, the final piece I wanted to just go over at very, very high level before going into each one a little bit better is the license manager. Now, the license manager is essentially what does, as it says on the tin, it licenses your entire deployment. And if you're not sure at the moment, we actually license on the size of data in gigabytes that you ingest within a 24-hour period. Now, that's not existing data, that's new, fresh data. So we always call it hot data, data that's being written and read from at the same time. So any new data between midnight and midnight, it's going to count towards your license there. Now, I always get a question at this point normally, what happens if we ever go over our license? Normally, especially because it's size-based, if something goes wrong, normally you will see more logs than less. Now, we do have a what we call gracious license system. So essentially, you get 4 days grace period. So if anything was to happen, you have 4 days to resolve it. Then on the fifth day, oh, sorry. Then on the fifth day, it's going to lock out your searching. So it's going to prevent you from doing all those searches, dashboards, and reports that you are using Splunk for. Now, I won't ever stop indexing your data. We'll always keep on indexing your data, and essentially all you need to do is get a license reset key from Splunk support and essentially explain what happened, tell them what's going on, and then they would help you out with that and give you the license reset key. That would then unlock your searching again, and you're good to go. As long as that doesn't happen, too often within your license period, then we just consider it kind of a flexible option. And, we don't ever come asking for more or anything like that. Don't worry. If there ever is an opportunity where, for example, there has been several months or over, half of the year where you have been breaching the license, then you would be urged to upgrade. And we would work with you to obviously understand where it is that you're breaching, try and help you get within your limits. If that isn't possible, then obviously we'll try and find the best way to size you up, but only maintaining the data that you actually need to search. And that's something that a lot of people don't do, and we can talk about a bit later on as well, is kind of leaning out your data, I always say, and only ingesting, the stuff that you're actually going to need in an audit report or even investigation. Those informational events or those big proxy descriptions at the end of Windows events are probably not going to be that helpful. So let's go ahead and just remove them out the events. So before I go into each individual kind of piece a little bit more in depth, does anybody have any questions? I don't want to make, oh, sorry, I don't want to make sure that I miss them. I want to make sure I don't miss them. Okay. So let's talk about the forwarders in a little bit more detail. Now, you might start freaking out when I start naming config names of config files at you, but please don't worry. Um, what I normally just say is just think of them as in like a text file. Sometimes people get really concerned when they're working with config files because they think, oh, I'll put one full stop in the wrong place and it's all going to go bang. Don't worry, just keep backups. That's what I say, keep regular backups. Make changes on a test system before putting them in production, and you will always be fine. Never anything to worry about. Now, when you're configuring a forwarder, if you're on Windows, then you get a nice UI setup, I will say. You're very lucky. And you can literally click through and it will ask you, where are my indexes? Do I have a deployment server? You can just put in the host name or IP address and then also the port number that you'd like it to use. Now, the default for sending data over to the indexes is 9997, and the default management port there is 8089. Now, Splunk will allow you to change those. So if you ever do want to change them, you're more than welcome to. I would always just say to, first of all, remember what they've been changed to. And second of all, also keep a note of them so that if you ever do raise a case or anything like that, just be sure to let us know that the port number is changed, because otherwise we might think, oh, well, that's the root of the problem, obviously. Now, if you ever do have to work with a forwarder in the configuration files, you're not doing UI setup, or maybe you're editing something after it has been deployed, these are kind of the four main configuration files that you guys will be working with. Now, the first is inputs.conf. Now, inputs.conf is essentially all of the data inputs that you're going to do. Now, I will always say by like the bare minimum that you should give it is obviously the path of where the location of the data is. And I always say try to be as specific as possible in those, only because it's going to allow Splunk to read that data a lot quicker. And sometimes it can also create CPU load for the endpoint that it's on when it's trying to read loads of different folders and trees and tiers in the folder. It can start causing a lot of problems, especially if you're dealing with lots of wildcards, one after the other. It's going to obviously try and read everything there, and then, go down again. So it is a bit of a problem if you're to use too many wildcards. But again, if you do need to do, if you put all your logs in one particular place and that's just called logs in a folder somewhere, you want to do logs/start, then by all means go ahead and do that, because obviously you want it to read all of that. Now, the other things that you need to give it are index, source, and source type. Now, if you are putting index and source type in the inputs.conf, what I will always say is you do have to make it on the indexer. I have had a few support cases in more recent times with people making the name of an index on a forwarder, but they're not actually making it on the indexer itself and thinking that it will just automatically make it. It doesn't do that, unfortunately. So if you're making an input and you want it to go into a new index, the first thing I would suggest to do is to make it on the indexer first. And then once you know it's there, then you can put that name into the inputs.conf so that then it knows where it's going. But if not, then I would say to avoid kind of specifying it on the forwarder altogether, if you're not going to put it into a separate index. Or if you have made it on the forwarder and you haven't made it on the indexer yet, then all it's going to do is it's going to come up with a warning message inside of Splunk and tell you that it's received events for an index that's not been specified, and that it just doesn't have access to that. You can either make it retrospectively, but the only thing I will say is that those few events will drop off into main by default, and then you would need to either get them back out or delete them out and then kind of start again. So it is always good to have your indexes created ahead of time. Now, the other thing I would say with inputs is something that always gets people is if you don't have the correct permissions for the user that the forwarder is running as. So the forwarder will run as a particular user on your system on the endpoint. Now, you need to make sure that that user has access to read to the data that you want it to index from, because otherwise it's not going to be able to see it. I get a lot of support cases with people, setting up inputs and all of a sudden they can't get any of the data in. They think, the Splunk config's all looking right. There's no errors that look, anything strange inside of Splunk. And then all of a sudden you just see all these permission denies over and over again. And it's just from the user trying to read stuff that doesn't have access to. And believe me, it happens more times than you would think. So always check that. Or if you, for example, have an input that stops working all of a sudden, definitely check that the permissions of the file that it's trying to index haven't changed, because sometimes it could be somebody else changing the permission, especially on Linux. Chmod is all too easy to do. And then all of a sudden you have taken away the access from everybody inside of your organization apart from yourself. So it can be a real problem. Now, outputs.conf tells Splunk where to send the data, where the forwarder should send the data to. So in there, you should put the either the cluster master name, or if you don't have a cluster of indexes, then you should put in the all of the indexers, host names and ports. Or if you just have a single indexer, standalone one, then just put the one in. Now, server.conf tells it things like, for example, what is my server name and all of that good stuff. And that really will normally get automatically created, but with the defaults of the host name of the machine. But if you ever want to change it inside of Splunk, then I would recommend change it in server.conf, and then you're kind of set up. Sometimes people want to change, the server names from architectural names to, Splunk Indexer 01, Splunk Indexer 02 type of thing. So they can make it a bit easier to understand where the problem is arising from if you're ever trying to investigate a problem across your tier. It's easier to see Splunk Indexer 01 than it is, SKU 94701. Now, you also have deployment.conf. Now, deployment.conf is going to be for the deployment, and I think it's actually deploymentclient.conf, please forgive me. But that is essentially where you're telling it where the deployment server is. So if you did want it to be managed by a deployment server and have its config sent out to it, then put the deployment.conf in and give it the hostname or IP address, and again, port that you want it to contact the deployment server on. Now, something I would normally say is the easiest way to set up a folder, at least my personal favorite way, is to use the set deploy poll command, which can be run from the bin directory. Now, essentially, all you do is you put in Splunk set deploy dash poll, and that means that it's going to try and set up a deployment server and make a poll connection to it. So you put in the, again, host name and port number that you want it to use after that. What it would do is make the initial connection to the deployment server, and then you can do all the new configuration through the deployment server then, so you can give it the inputs and the outputs using the deployment server, using the deployment apps. So it's much easier process. It also gives you centralized management straight away, and also means that you can have commonality across all of your different forwarders. So for example, if I'm just deploying a Windows forwarder out to a new server that we've had set up, then I can very easily just put it into the Windows Server group, and I know that it's going to immediately get all the config for all of its other peers. It's going to be a direct copy of all of the config that they get, and I'm going to be able to make sure that we've all got the right data coming in without needing to check individual config files or anything like that. Now, if you ever are going to edit these, they should live in ETC System Local. If you don't see them in ETC System Local, then you should go ahead and create one in System Local. Now, you can also edit these in etc/apps, and that will also work in apps under local. But system does actually take first precedence. So anything you put in etc system local will take precedence over anything in apps. So it is kind of the highest of the hierarchy there. So it's always good to put stuff in there, especially for inputs and outputs, because those sorts of things you're going to want to be the same no matter what. So it's going to give you a lot more kind of, I guess, ambiguity. If I put my teeth in this morning, over what's actually being ingested, because sometimes it can just be a case of, oh, this input is taking precedent over this one, and now all of a sudden we're not having data in. Happens all too often. Now, there will also be a copy of these under default, so etc system default and also etc apps default. Now, you can edit the default. There's nowhere to say that you can't, apart from here. But what I will say is that when you edit the default, you leave yourself open to basically losing all your work, because when we upgrade Splunk, it overwrites the default files. So if you haven't kept anything in local, then all of a sudden all your hard work is going to go to waste. What I would urge you to do, if you ever do only see the file in default and you're thinking, oh, do I edit it here? Do I make a copy? Just make a copy of the file into local and then make the changes inside of local. Don't worry, you're not going to duplicate anything. Don't worry, you're not going to have loads of, duplicated data inputs. It will only read it from the highest precedence and then try to take any additional settings from anywhere else. So at least you can do, your additional settings there, and you know that it's the correct way. Now, I normally say that the best way to get it up and running with knowing how to deploy forwarders is by trial and error. And I always say deploy one to your laptop, set up the inputs and outputs to just a little Splunk instance, free instance that you're using. Set up the input, make sure your data is coming in, and then delete it and do it again. That's what I did. Trial and error is a great way of learning Splunk anyway. Okay, so we're just going to move on to indexes and kind of how buckets work and all that kind of thing. And we're going to see some really bad drawing right now. So please forgive me for this really bad drawing. So what I wanted to talk about is the way in which that Splunk is, the way in which that it indexes your data. Now, when data is being written into Splunk, essentially it goes into something called a hot bucket. Now, a hot bucket is data that's being written to and read from at the same time. So when data gets indexed into Splunk, it goes into something called a hot bucket. And as I said, these are being written from, written to and read from at the same time. Now, hot buckets are, and buckets in general are essentially just the way in which the Splunk parses and also moves your data through the retention cycle, okay, based on your preferences, whether that's in size, so gigabytes or terabytes, whatever you want, or whether it's in days, hours, minutes, whatever. Now, Hot data is that data that's still being parsed, okay? It's still being, timestamped, all that kind of stuff, or it's only just been timestamped. Now, normally the average time for data to be in the hot bucket is around about 3 minutes or so, but it can vary depending on the velocity and volume of the data that you're having put into Splunk. And Splunk will automatically size that for you, so you don't ever need to worry. Now, if you restart Splunk, or if it reaches that time period that Splunk thinks is right for it to roll, then it will roll into something called a warm bucket. Now, your warm bucket is most of your data. It's where I normally say it lives for most of its life. It has a white picket fence, 2.4 children, etc. And your warm buckets are going to be the most quick to search. Now, this is because Splunk manages them a lot better than, say, the hot buckets or the cold buckets, which I'll explain about in a minute. Now, this is because it expects your data to live in warm for most of its life, as you would expect. And once your data is reaching its retention period, whether that's in time or size, then it will go ahead and roll into cold. Now, cold data is going to be quite slow to search because the buckets are very large, and that's mainly because cold data is going to be archived soon. So cold data is kind of put into a bucket of, 12 to 24 hours, and then as it ages out, then it will be archived off. And what we call our archiving process is called freezing. We kept with the temperature kind of analogy here. Now, frozen data cannot be searched. It is going to be automatically deleted. If you don't tell Splunk where to send it to, we'll automatically delete it for you. If you want us to archive it off to a different location, like some NAS storage, maybe you've got some blob storage somewhere, you've got some S3 buckets you want us to put it into, or just some cheap on-prem colder storage, then we can go ahead and do that. We just use a script, to go ahead and archive the data off to whatever location it is that you want. Now, the default period for this happening is 7 years. So I normally say if you have ever made a mistake and you haven't set up retention period or archiving, normally you've got more than enough time to realize and rectify it in the meantime without anybody knowing. And obviously, if you haven't set one up, then the default will just be 7 years or 500 gig, whichever gets reached first before it starts purging data. Now, again, different retention periods can be set per index. So if you wanted, one data set to have 60 days and then one to have a year, then just put them into two different indexes and you can set up the retention requirements based on that. What's great as well with Splunk is the fact that hot and warm can live on different storage to cold. So something that I, as a kind of infrastructure cost saving that a lot of people do, is put hot and warm on faster storage and then put cold on slower storage, and that's going to give you a much kind of cheaper storage cost there because your cold data is going to be quite large, but you're probably not going to be searching across it for very long. So it's a great way of kind of just mitigating that cost there of how expensive storage is nowadays. So that's essentially how a bucket works, and that's really how we deal with the retention and moving your data through that process. Now, the buckets themselves on the back end, they just look like, again, more subdirectories. So you see your index, you'll see a folder called your index name. Then you'll see 4 folders below them. You'll have your hot DB, warm, cold, and then frozen as well. So if you did want us to freeze it to a location literally in the same place, then we can do that too. Now, below those DB folders, you'll then see a load of text files or log files, flat files, and those will be your individual log events that have been put into those individual files. And that is how we deal with all of your retention and moving the data through that process, and also, reading that data back to you in an easy and quick way. So in the case of clustering, really all of the peer nodes take on the task of parsing and indexing the data. Now, the way in which the process works is that the cluster master will basically give the task to a particular indexer depending on how busy they are. So if you've got loads of searches being sent off to one particular indexer, then that one won't deal with any indexing of the time period, and then it will have just the data replicated to it, and that's how the cluster will kind of replicate and rebalance itself. Now, in the event that the cluster master goes down, the peers will independently try to index the data. The only thing that won't happen is the replication across them. So you may get incomplete or partial results, and that's mainly because, if indexer 1 gets the data and then all of a sudden your search query goes off to indexer 3, then because the data isn't being replicated, you won't end up with those logs in your search results. So you may see incomplete or kind of false results there. So let's move along to the search heads and searching here. So our search heads are, what run all of our pretty things. They do all of our searching, and pretty much anything inside of Splunk is a search. A dashboard query, a report, an alert, anything that you're scheduling to run, they are all individual searches. Now, something that I always say to people that I think people often forget is the fact that the way in which that Splunk uses CPU means that in the event that we're running so many searches at one time, we actually tie up a core for each of those searches. So if you're ever trying to capacity plan, think about how many searches you want to run at one time, and that is how many CPU cores that you're going to need. Now, that can often reduce people's need for real-time searches. If they come to you saying we need everything in real time, you say, okay, that's fine. You just have to pay for the hardware to run all those real-time searches. And then all of a sudden they say, oh, okay, well, no, every 5 minutes is more than enough. And that's what I normally say to people. Unless you have somebody physically there all the time, running searches on a 1 minute or 5 minute interval is a much better performance-wise option than running everything in real time, because it's going to tie up those CPU cores all the time. Now, again, with search heads, you can cluster them, and your search heads, they have dynamic captaincy, which is great. So the captain can switch if you restart. The only thing I will say is that it does mean that you have to find out who is the captain before you make any changes out to them, because if you do want to deploy an app or anything like that, you should be doing it from the search head captain and then having it replicated across. Now, again, it will replicate all of those dashboards and reports and alerts that you make across the different peers here. And what the captain, sorry, I shouldn't say cluster master because we call it search head captaincy. What the captain will do is use a artifact registry, which is, I always call it just a big register of where everything is and who has it. And it will use that to make sure that all of the members of your peers, all of your search heads, have the same copies of the right thing. Now, if you either are looking to run any searches or anything like that, I would always say to have a look at Splunk Base first, because it is a really, really good free resource for out-of-the-box dashboards, reports, and alerts. Now, if I just put space in here, you can see we've got over 2,000 applications now, which is amazing. And these aren't just small homegrown apps. These are built by some of the biggest players in their respective fields. Pretty much all but 5 are free. So that is going to give you a lot of value without the need to write huge queries or loads of SPL or anything like that, which can sometimes be a little bit too much, especially if you're just getting started. Now, all you have to do is just put in the name of the data source or, data type you're working with. So say, for example, I've got some Cisco data and I want to see what I can get for that. I can go ahead and now see all of the different apps and add-ons for Cisco. And so I might want to, for example, use the Cisco Security Suite. And this has out-of-the-box reports and dashboards that I can use without having to do anything. So I can literally download this, install it, and look like a wizard. Now, I would always say to check whether or not a app is an add-on or an app. And the kind of defining factor is that if it's an app, it's going to have visualizations, it's going to have views for you, pretty things, and dashboards, reports, alerts, etc. And then if it's an add-on, it's going to deal with the normalization of that data. So when we're sending data into Splunk, I mentioned something called a source type, and a source type is how Splunk is going to read that data. Now, source types can be dynamically edited. It's never a problem to do that, but sometimes you will face issues if you are dealing with something really, really complicated. Building the source type can sometimes be a little bit of a trial, shall we say. Now, an add-on will have that source type pre-written for you. So all that event breaking, where the timestamp is, field extraction, will all be done for you. Now, I'll always say apps should be deployed out to the search heads only, and an add-on should be deployed wherever the data is being parsed. So if the data is being parsed by a heavy forwarder, please deploy it out to the heavy forwarder. And if the data is being parsed by the indexer, then put it on the indexer. That's the easiest way to kind of understand where something should go. Okay, well, let me finish off then with something called the KV store. Now, a lot of people don't know what the KV store is sometimes, or how it relates back to Splunk, but a KV store is essentially our way of storing anything that would be best stored in a database table. So we run a MongoDB to run our KV store, and essentially we use it for, by default, user level preferences, session data, and you can also any accelerated schedule searches or summary indexes will get put into the KV store as a new collection. Now, a collection is just the table. The records are, the rows within that table. The fields are the columns within them. And then you get two individual fields across every single KV store collection, no matter what, and that is underscore key and underscore user. Underscore key is just a number to define the row, the record to call back to reference. An underscore user is automatically created. It's just a Splunk generated number just to keep a count and a record of how many KV store collections it has, how big they are, how many rows, etc. Now, the KV store can be used for a lot of different things. For example, as I said before, if you accelerate a search, it's going to get written to the KV store, etc. But you can also do things like metrics indexing, which is using the KV store for that. And there is also options about, using the KV store for search efficiency and making your searches faster, especially if they're run on a very frequent schedule. So lots of applications like ITSI and enterprise security will use very big KV store collections to keep a track of incidents or to keep a track of all of the search artifacts that it's got. Now, whilst you can do a lot of things with the KV store, I'll always say, please, when you're making changes to the KV store, please do them with extra care, extra TLC. The KV store can be something very tricky to bring back up if it ever does get corrupted or something happens. And it often is not backed up to its most recent state, because it gets written and edited to very, very frequently. So, if you're taking it back up every day, then you would still lose, your day's worth of your KV store items, which can be quite a large amount of data search results and, queries and such like. So it's definitely something to use, but if you are going to use it, just make sure that you have everything correct, you're checking your documentation, or perhaps you just use a professional services engineer to come in and do whatever it is in the KV store that you would like for you. That's what I'd normally recommend. We talked about the deployment server a little bit earlier on, and hopefully that gave you a bit of detail into that. If you do want to know anything more about the deployment server, though, don't hesitate to give us a shout. Now, I am aware of the time. I've been yabbering on for a little while now about a lot of kind of architectural stuff. I just put on the screen some useful links and also our support contact information. So if you are engaged in a proof of concept with Somerford, or if you are an existing customer, you do get access, and every single member of your business gets access to our support desk. So if you ever need to reach out for support, then please either give us a call or you can email us at support@somerfordassociates.com. We have a 1-hour SLA for a case to be raised and an engineer to get back in touch with you. So hopefully it shouldn't take too long to resolve your problem. Again, we have more workshops and webinars, and if you are looking to get more of a hands-on approach, I would urge you to come along to our Intro Texture workshop, which we run up and down the country and also virtually. You can find all of those at somerfordassociates.com/events. There's also workshops on ITSI, enterprise security, and newly coming up business flow as well. Please don't hesitate to get in touch. Again, you've got our numbers and our email. Or you can alternatively join another webinar and you can ask it then. If you are going to attend one of our workshops, I look forward to meeting you properly then rather than virtually. And if not, I hope that you have a great day and a great week. And thank you so much for joining.